my good old calculator. It's actually my phone because I have Android. I got that Android game. If you don't have Android, I'm sorry. You have to do this on your computer. All right. So what we did last class would help you with this part. If I say find the integral, the antiderivative of this. So how would I do that? Antiderivative. Remember, some of you probably already did it in your head. We're using this formula. X n plus 1 over n plus 1. And so, actually, yeah, has anybody already done this in their head? What would the answer to this be? Remember, if you put this little symbol here, that means integration or antiderivative. For dx, that means with respect to x, because we have an x variable there. So anybody know that? What is the antiderivative of negative 2x plus 5? I know it's so hard. I thought it was too easy, but that's not the answer. That's just the description. Well, if we forget, let's just do it together then. So I have negative 2 x to the first plus 1 over to the n here was 1. 1 plus 1. And then I have plus, you see there's x to the 0 power here. So then I'm left with 5x 0 plus 1 over 0 plus 1. So I end up with, what is that, negative 2x squared over 2 plus, 5x over 1. And then, yes, Adam's right, got to add the plus c. So then if I reduce that, I get negative x squared plus 5x plus c. We're done. So that was just the antiderivative. I want to go backwards. If I take the derivative of this, I'm going to get negative 2x plus 5. So again, if I do power rule, that'll be 2 different colors. It's different. The power rule, this derivative, derive. So x to negative plus 5x plus c. That goes in front. Negative 2x. Then that's a 1 that goes in front. So that's just plus 5. Minus 1, minus 1. So I don't put x here because x to the 0. And this is a constant. So the derivative of constant 0, that's why I have to put c there. So then this is our answer. Same thing as this here. That's how you check it and know you did it right. So I know everybody's got this. That's easy. Now, you might see something, well, actually, yeah, I'm lying. You are going to see something like this. So if you look, it's the same exact function, but now you have these little numbers here. What are these? Well, before, we took the antiderivative of this function over all x, every value of x. That's what that means. So those aren't exponents. This is saying, okay, now I want you to take the antiderivative, but I only care about what's between 2 and 0. So on the x-axis, actually, we'll flip it over. So we'll say between 0 and 2 on the x-axis. So this is x-axis here. This is x. I only care about what's happening between here and 1, 2, and here. So if we actually draw the graph, I'm going to show you what I mean by that. I actually drew it for you right here. So so this red line, that is the graph of negative 2x plus 5. What's shaded in purple is your antiderivative, your integration. What you're doing, the integration is finding the area under the curve or the area under the line. And to prove that, we're going to find the antiderivative from 0 to 2. And we can do that on the calculator here. So on the calculator, if you press alpha, I can turn it on first, alpha, and then go to, you see y equals here, you see all these f1s, f2s, f3s, whatever. We want f2. And you see here number 4, fn integral, that means function integration. Press number 4. Ooh, look at that. So the starting point is always on the bottom. The end point is always on top. We usually say A, and that's B. From A to B. That's A, B. From A to B. So 0, that's where we start. We end at 2. A good way to remember this is Drake. Start at the bottom, now at the top. Negative 2x plus 5. And then again, we want to tell the calculator to find the antiderivative with respect to x because we have an x in our equation. X. Enter. Ooh, we get 6. What that's saying is from 0 to 2, the area under the curve is going to be 6. And you can check that on the graph here. And sometimes we'll be given problems like this, and they'll say, hey, what is that area under the graph? You either do it in the calculator like this, or use the graph. If sometimes they don't give you the equation, they'll just say, hey, find that area. Well, let's do this. To get the symbol, you do alpha, I think just window, alpha window, and the number 4. Like that. So now I said, okay, so from 0 to 2, our area was 6. That's what the calculator said. Let's check that. Well, I've got this shape here. That is a rectangle. And this rectangle is 3 by 1. So 3 times 1 equals 3. So then this is 3. That's the area right here, 3. And then let's see, we have another shape here. It's a square. Square is 1 by 1, 1 by 1. So the area here is going to be 1. That's 1. Then we have a triangle here. What is it? So in the calculator, we're writing the function and we're finding the antiderivative. I think you're getting confused about that. Yeah, so we're given a function. They're saying, okay, can we go backwards? Okay, so this is a triangle. So triangle is 1/2 base times height. The base here is 1. That's 1. There's 1. The height here is 1, 2. So height equals 2. 1/2 1 times 2. And that would be 1/2 times 2, which will give me 1. Let's use a different color. Let's say, so this is 1. This whole thing here, area equals 1. And if you look here, isn't this the same shape? So the area here equals 1. So now we have 1 plus 1 plus 3 plus 1. I wonder what that equals. Plus 3 plus 1. So 1 plus 1, don't laugh at me, I need these. Plus 3 plus 1. Oh, I get 6. So then that's our proof. That shows us, okay, when we find the derivative, or the integral, we're finding the area under our line, or under our curve. And when I told you sometimes you're not given the equation, it'll look like this. So our practice is on delta math today. And so they'll say, okay, find the integral between -9 and 7. So from here to here, right here. Find the area under the lines here. So we just divide them up in the shapes. So we have this shape here, and then we have this shape here. It's a triangle. We have another triangle right here. And we'll just find those areas and add them up. But before you think, okay, this is so easy. Well, I mean, it is. But if you notice, all of these are above the x-axis, which means they're all positive. If you ever have anything below the x-axis, your area is going to be negative. So you'd be adding a negative. An example of that would be this here. So here, they want us to find an area from 0 to 9. 9 here. So from here all the way to here. So this part here, we'll get a positive area for. And actually what you'll be doing is you'll be separating it into two triangles. So this is one triangle here. Find the area of that triangle. Second one, find the area of this triangle. Add those together. And then the last one would be this one, this triangle. But since it's below the x-axis, this will be negative area, which just means you'll have 1, 2, and then the third triangle will be negative. So that's negative. This is positive area, and so you just add those together, and then you'll get your total area. So that's all we're doing today. And most of the stuff, like I said, calculator work, except when they give you the graph like this.